Hi all, this is Yuvraj Jana, and I'm making this video for Coursera assignment for the course AA Product Management by Duke University. The project description is very clear. We need to build a model to predict the electrical energy output of a combined cycle power plant. The feature set that were provided are temperature, ambient pressure, relative humidity, exhaust vacuum, and there are totally 9568 data, right? And the approach I have taken is, as I have already mentioned, there are four features. We had to select the features, so we had to find out which features we can select. For this, I had plotted graph for each feature against the output we are trying to arrive, which is energy output in this case. And once the correlation is done, we can probably do the feature selection. And in this case, I notice that all the features seems relevant, and based on the domain knowledge as well, it seems like energy will be certainly dependent on all the parameters that were given. I went ahead with the assumption that all features are valid, and the next step after feature selection is to choose the algorithm. In this case, I've gone ahead with the linear regression algorithm as a first step. It is always a good one to approach. And I also went ahead with the identifying the parameters such as coefficients and intercepts in order to get an output model. And yeah, finally, and not the last item, right? I had to classify the data such that 80% of the data given is used for training and 20% of it is used to test once the model is arrived. Right? Within that 80% of the training data, I had to separate that into four different sets of 1913 rows each, and then the fifth set, of course, the trace set, which had 1916 rows, and then finally the efficiency of the output matrix was calculated. In order to do that, I had used regression matrix error by using mean square error, mean absolute error, and mean absolute percentage error, right? And I'll move on what all I did. So this is the data given, and I had to plot different data, how it is correlated with the output, which is the energy output in this case. So as you see, there is a clear correlation I noticed between the first two features. And if you notice, even for ambient pressure, there is an increasing trend. And then also the relative humidity, there is an increasing pattern, right? So I went ahead with the assumption that all features are valid. And then, as you see here, the entire data, still with the there is 9568 data. So I split it into four different modules uh, or train set. So it had 1913 data each, right? And yeah, so I used the Excel model of output for each of the train set, and then I ran the data analysis, and then the data analysis output is captured here in each of the tab of four different training set, wherein we have the multiple R square, standard error, and things like that, and we also had the coefficient for each of the models, right? So this was captured for all the four training sets, and then yeah. So in this sheet, I had put a summary of all the data for set one. What is the intercept? what is the coefficient for each of the models for linear regression, and also the output regression statistics for each of these sets, right, in the training model is captured here. As you see here, this model had a standard error, so I thought this is the more efficient way, efficient coefficients, and this is the model I used. Uh, Even though this is the model I selected, I did the efficiency check against each of the sets in the test model as well. And again, as you see, output efficiency, uh, again, the mean absolute error is the lowest, not the lowest, but mean absolute percentage error. It's the lowest for the set 3. So this is what I did for the project. Please let me know if in case any additional input is required. Thank you.